Let's take example number 3, or a third example. It was a 26. There is a very, very useful question that might be asked right now. And the question will be, Sajjad, the broadcast ID of the previous example was 10.0.0.63. Is that correct? Yes. Does that mean 10.0.0.64 is another broadcast domain? Correct. Is a new network? Yes. So we can use it on another different network and it will not overlap with the first one? That is correct. Will we see that? Yes. In the CIDR topic, we will see it. 10.0.0.64 is a new network ID for a different broadcast domain. Keep it in mind. Now, for today, let's take another example. An example that can look like, again, let's say 10.0.0.0 for simplicity. And this time, remember, subnet mask can range from 8 to 32. And based on the two examples that you and I have solved so far, /24 gave 200 plus IP addresses, /26 gave 60 plus addresses, meaning that the bigger the subnet mask, the smaller the range. Because /26 gave 60 addresses, /24, a smaller one, gave 250 plus addresses. Don't forget about that. So if you and I ever saw /23, let's have it in a different color, /23, what should we expect? A bigger network than /24 and definitely bigger than /26. And I hope that I will write the diagram of multiplications for you before I finish this course. Let me start. And starting will look like this. All right, subnet mask 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4. Oh, I'm sorry, 23, 24. So 25, 26, 27, 28, 29, 30, 31, 32. And this leads to a network portion and a host portion. It looks like the first octet is locked, the second octet is locked, the third octet has some flexibility, as well as the fourth octet. This is starting to become a little bit more complicated. So yes, this is the third out of 5 examples. So stay tuned because things will become more difficult, but I will be certain, I will make sure that it will stay simple for you, adding extra steps to take into considerations to keep things as simple. All right, let me go again. Same rules, you and I again. These rules says 32-bit minus 23-bit from the subnet mask equals to, was it 11? It was 9, I'm sorry, what 11? It is 9. So this leads us to 2 to the power of 9 using a calculator. This will equals 512. Good. 512 is the increment value. 512 is the total number of addresses. 512 minus 1, which is network ID and broadcast ID, equals 510. 510 is the usable valid range of IPv4 addresses. But the challenge today is to complete things up or lock things up, or let's say obtaining the network ID, broadcast ID, and the valid range, because this is what the VLSM examples are all about. Obtaining the network ID, broadcast ID, and the valid range. Okay, the network ID is in the example. Fine, 10.0.0.0 is the network ID. I have no issue with that. I hope that you don't have an issue with that as well. All right. The very first usable IP, is 10.0.0.1. Scratching my head, I'm starting to become a little bit worried, thinking a little bit too much. Now you want me to find the broadcast ID today. and the increment value is 512. So your point is I should start counting 0 from the fourth octet to the right side, 0, which is the network ID, 1, 2, 3, 4, 5, 6, 7, 8, 9, until I reach the 512th value. Isn't that a little bit more difficult? Like I know in the way, the fourth octet will be filled when I reach 255, and it's impossible to say 256. So what will I do? I will have to jump back a counter to the left, increase 1001, start the 1001, and then continue counting. You mean you just meant, let me have a notepad in order to maintain my sketch. You mean that I can see 10.0.0.0 as a network ID, .0.1 as the first IP, in the way we might see .50, in the way we might see .221, until we reach 255. It is impossible to see 56, no way. So you mean that I can go for 1.0 and then continue 1.1, continue, let's say 1.20, until we reach the last one, the broadcast ID. Is that correct? Yes. Yes, because a single octet is only 256, let's say, values, only 256 values at maximum, ranging from 0 to 55. So yes, I have to take a counter back, increase it, start a new beginning. Is that a new broadcast domain? No. Why? It's a /23. There was flexibility in the third octet. There was a flexibility here. That's why this 0 can be 1. And we are still within the same domain. That's why, because of this 0. Because the third octet has a flexibility now. So I need to start increasing on this one, made it 1, and then went back to the fourth octet and adding 10.0.10, 10.0.1, 10.0.15, 10.0.20, 10.0.50, 10.0.100, until I reach the broadcast ID. Well, continue to count on your fingers. No way, I'm not doing that. Then you can take a basic rule that I derived by myself, and to be honest, I really have no idea if it was ever mentioned elsewhere, because in the end, math is math, and you will find it someday in another place or another book, because it's a mathematical way, so it has to be there. Like the way says that when the increment value is bigger than, let's say, or equals 256, bigger than 256 is a big number, just like 512, then what you should do is that you should divide it on 256. Divide what? The increment value. When we found out the increment value was 64, fine. Start from 0 up until the odd number, 63, done. When we find the /24, which is 256, fine. Start from 0 up until 255, done. When we find it some big number, today is 512, and the next example, which will be much bigger, and the example after, etc., it depends. So this makes it more difficult. And if it makes it more difficult, then at that point, I need a method. The method says that take this big increment value, divide it on 256 until the result is smaller than 256. You mean multiple dividing can occur? Yes, I will make sure that example 4 and 5 are much more difficult so that you will get the idea. Don't jump to example 4 and 5 before you master example 3, 2 and 1 as well. So 512 divided on 256 equals, use a calculator, help me, it equals 2. It equals 2. 2 is the number of octets that should be filled. For simplicity, deduct 1 from the result and write what's left from the result. Well, it's actually 2. So when I deduct 1 from 2, only 1 is left. And what I will do right now, let me have it in a different color. This deducted 1 equals a filled octet on the right. Do you remember how to fill an octet? Which number should be written to represent a filled octet? Filled totally? 255. Done. And for the other number, take it as it is and have it here. Done. What about the first and the second octet? Well, their shadows are locked, so they will be downloaded as they are, and they will never be changed. One step before the broadcast ID is 10.0.1.254. I hope that I made a little bit, let's say I delivered a little bit more new details today, because there will be example 4 and 5 before I close the file of VLSM. So network ID and broadcast ID and the valid range. Review it, do it by yourself, paper and pencil, a lot of practicing, really a lot of practicing before you proceed with this, with the next video, before you proceed with VLSM, and before you finish this course. Thanks again.